Today I'm gonna talk about the derivative of composite function application of two Trig rules. We're gonna focus on the trig function and exponential function. Now let's talk some about the formulas. The first formula is the typical Trig rule. The capital F can be any trig function. For example, if capital F is sine, the derivative of capital F gonna be cosine. If capital F is cosine, then the derivative of capital F gonna be negative sine. If capital F is tangent, then the derivative of capital F gonna be secant square. And the second formula is the derivative of composite exponential function. The derivative of e to the power fx equals e to the power fx times the derivative of fx. And the third one is standard power rule. And the fourth one is constant multiple rule. And I also list three derivatives for trig functions. Now let's take a look at the first example. The first example is about the derivative of e to the power sine 2x. Okay, it's very clearly when we compare this example with the second formula, we can tell what is little fx. The little fx equals this guy, sine 2x. Now we can follow the formula 2. We're gonna get e to the power fx. That will be e to the power sine 2x. Okay, and then we do the derivative for the sine 2x. Now let's focus on the derivative of sine 2x. Okay, and we're gonna apply the Trig rule. And let's take a look. What is the capital F? The capital F is sine. What is little fx? That is 2x. Right. So we can write down the little fx equals 2x. Okay, now we copy the first term, e to the power sine 2x, and the capital F is sine, so the derivative of capital F gonna be cosine, and fx 2x times the derivative of fx, so will be 2x prime. And here the derivative of 2x, we're gonna apply the constant multiple rule. So we have what? We have the constant times the derivative of x, which is pull the constant from the derivative. Here we pull the 2 from the derivative. Okay, and here we have a very special case, derivative of x. We can apply the power rule. That should be 1 times x to the power 1 minus 1, x to the power 0 equals 1. Okay, so we can simplify it. So here is 2 times the derivative of x, right? Should be 1. So 2 times 1 equals 2. We got cosine 2x times e to the power sine 2x. Okay. Now let's take a look at the second example. For the second example, we can tell what is fx. Fx is this guy. We can just write down as fx equals 4 times tangent x plus cosine 3x. Okay, Now we can follow the formula. E to the power fx. So fx is e to the power tangent x plus cosine 3x, and times derivative of fx. We have 4 times tangent x plus cosine 3x. Okay, now let's take a look the derivative of these two functions. Here is the derivative of the sum of two functions. That means we're going to do the derivative for each function. So we have the derivative for each function. Okay, and let's take a look at the first function. The first function is a constant times the tangent x. So that means we can apply the constant multiple rule. Right? So we can pull the constant out of the derivative, and we times the derivative of tangent x. Okay, and for the second term, we're gonna apply the chain rule. Here, the cosine is capital F, so derivative of f gonna be a negative sign, right? We also have the little fx. That is what? Is 3x. Okay, 3x. Now, let's simplify it. E to the power 4 tangent x plus cosine 3x, and for this term we're gonna get 4 times secant x squared, because the derivative of tangent x is gonna be a secant x squared. And for the second term, we apply the chain rule. The derivative of capital F, here's cosine. Derivative of cosine is negative sine. Fx is 3x times the derivative of fx, that is 3x. Okay, and then we can simplify it. E to the power 4 tangent x plus cosine 3x. We have 4 secant x squared minus, now let's take a look at this guy. This guy again, we can apply the constant multiple rule. Should be 3 times x prime, right? So we have derivative of x prime should be 1. 3 times 1 is 3. So we're gonna get 3 times sine 3x. Now let's take a look at the last example. For the last example, we can tell that fx is tangent cosine x. Okay, we just follow the formula here, and we're gonna get e tangent cosine x times the derivative of fx, tangent cosine x prime. Okay, and then let's take a look this derivative, and we can tell we're gonna apply the chain rule. What is capital F is tangent. What is little fx? That is cosine x, right? So we have little fx equals cosine x. Now we're gonna follow the chain rule. e to the power tangent cosine x, and here tangent is gonna be a secant square, and the fs is cosine x times the derivative of little fx, that is cosine x. Okay, and now we can tell for this term is what? The derivative of cosine x equals negative sine x. So we have negative. Okay, we put everything here, negative sine x, and copy this term, secant cosine x times e to the power tangent cosine x. That's it.